Good evening, everyone. Disha, you can send the pic of the answer to Jitin sir, okay? I will evaluate it and I will get back to you. Please send the answer to Jitin sir. Okay. और किस किस बच्चे ने अटेम्प्ट किया है आंसर? ओके सौम्य, जिसने भी अटेम्प्ट किया है वो भेज सकता है. आई विल इवेलुएट ओके 4-5 कॉपीज and obviously I will give you the model answer. It's okay, Disha. See, the first question and the second question, they were related and everything can be answered from the slides. You can go through the slides and both the questions can be answered from the slides. So today we are starting with a new topic, the gravitational waves. And okay, and before starting with the gravitational waves, I would like to cover one thing, which is the pollution control technology. And that pollution control technology is SCR, Selective Catalytic Reduction. And quickly, okay, we will do the Selective Catalytic Reduction. किसी के कोई डाउट अब तक लास्ट क्लास से या कोई भी डाउट साइंस एंड टेक से रिलेटेड? No doubts. Okay. So the technology is selective catalytic reduction. I will take the class of blockchain next week and most probably on Saturday. And if not on the next Saturday, then either on Monday or Tuesday. Okay. Today I was discussing with Jitin sir and he has assured me that he will give me a doubt class on next Saturday. And if it is not possible on the next Saturday, then we will have it either on the Monday or Tuesday. Okay. So I was talking about the selective catalytic reduction. This technique, it is pollution control technology. And कोई मुझे बताएगा ये किस में यूज होती है? Where we use the selective catalytic reduction units, SCR technology. Yes, Subhojit. These are used with the cars and specifically the BS6 cars, and they are used with the diesel engines, primarily with the diesel engines. And because SCR is an expensive technology, so we are avoiding manufacturing of the diesel cars because SCR, it is an expensive technology. We are avoiding the diesel cars. In fact, the manufacturing companies, they are avoiding manufacturing of the diesel cars because the rates, they will go up. So SCR technology, okay, with the BS6 compliant diesel cars, BS6 compliant diesel cars, we have to use the SCR units. Okay, And these SCR units, they will convert the harmful pollutants, the harmful gases that are released from the exhaust of the cars. ओके जो भी हार्मफुल गैसेस कार के एग्जॉस्ट से रिलीज हो रही हैं उनको हार्मलेस कंपोनेंट में कन्वर्ट कर देती है. So we are using it to convert the harmful pollutant, harmful gases into the harmless components. And I guess everyone knows what are the disadvantages, or what are the harmful effects of the nitrogen oxides. Everyone knows about the nitrogen oxides. Okay, so nitrogen oxides, they are responsible for, nitrogen oxides are responsible for
Ozone
yes,
depletion, sir.
yes, for ozone depletion and the formation of ground level ozone. Okay, yes, Priyanka, NOx emission, they are related to the acid rain, they are related to the ground level ozone, and NOx play a very important role in the formation of photochemical smog. Okay, so SCR point number 1 is, it is an emission control technology. SCR is an emission control technology. Note it down. This is the first point. Yes, NOx emission, in fact, the exhaust of the diesel cars, they are responsible for smog, the haze, okay, and the acid rain. And SCR, it is an emission control technology. This is point number 1. And SCR is used with the, obviously with the diesel cars, not the petrol cars. Okay, and they are used in the power plants. SCR technology, it is used with the power plants, in the boilers. Okay, and in the marine vessels. So we are using the SCR units with the cars, with the power plants, with the boilers, and with the marine vessels. So SCR is an emission control technology, and the harmful pollutants that are released from the exhaust of the car, the harmful pollutants, these are point number 2 is, harmful pollutants are the hydrocarbons. We have carbon monoxide, and the major culprit, which is NOx emissions, and the particulate matter. So these are the major pollutants that we are targeting. Okay, we want to convert these harmful pollutants into harmless component. So SCR, the use of SCR is that it reduces NOx emissions. It reduces NOx emission by 90%. Okay, they can eliminate nitrogen oxides by as much as 90%. And the harmful nitrogen oxides, they will be converted into nitrogen gas plus water. Okay, the nitrogen oxides, the harmful nitrogen oxides, they will be reduced to nitrogen gas and water, and these are the natural component of the atmosphere. They are not pollutants. So what we will achieve by using the SCR? We will reduce the NOx emissions by as much as 90%. Okay, Priyanka wants to ask something. She is writing a question. In which engine SCR is available? SCR, okay, this SCR is a unit which is used with the diesel engines. Okay, Priyanka, we are using it with the diesel engines. So we will reduce the NOx emission by as much as 90% using the SCR, and using the SCR, the emissions of hydrocarbon and carbon monoxide, we can reduce them from 50% to 90%. 50% to 90% reduction in the hydrocarbons and the carbon monoxide emissions. And as far as particulate matter is considered, we can achieve 30 to 50% of reduction in the particulate matter using SCR. So benefits of using SCR technology, they are huge. Okay, we can convert the harmful pollutants into harmless components. So how does this technology works? Have you heard about the diesel exhaust fluid? Diesel exhaust. Okay, so we will be using a diesel exhaust fluid, and diesel exhaust fluid, it is AdBlue. The fluid that we are using in the SCR units, it is known as AdBlue, and AdBlue is basically the aqueous solution of urea. Okay, AdBlue is the aqueous solution of urea. Is it fine? And the average rate of AdBlue is 127 rupees per liter. So if you are using the BS6 diesel cars and if your car has the SCR unit, then you will have to replace the AdBlue, okay, from time to time. And the rate of AdBlue is 127 rupees per liter. So in the SCR technology, what will happen? The NOx emissions, they will react with ammonia. Yes, Kritika.
So these diesel exhaust fluids, they are made of AdBlue or they just contain AdBlue. That's the only thing present in them.
See, diesel exhaust fluid, it is basically the aqueous solution of urea, and the name is AdBlue. The name of the aqueous solution of urea is AdBlue, and the general name is the diesel exhaust fluid.
Okay, sir. Thank you, sir.
Okay, Kritika, welcome. So the ammonia, it will reduce the NOx emissions. It will reduce it to nitrogen plus H2O. So this is the chemical reaction which is reducing the harmful NOx, harmful nitrogen oxides into the harmless nitrogen and water. Okay. And to accelerate the rate of this reaction, we are using the catalyst. And the catalyst is oxide of vanadium and tungsten. So vanadium oxide plus tungsten oxide, these are the catalysts used in the reaction. Okay, and these are used over the substrate of titanium to enhance the rate of the reaction. So the catalyst used is vanadium and tungsten oxides. Okay, so the rate of reaction is increased by the use of a catalyst, and that catalyst is vanadium oxide or tungsten oxide. And this is the reaction. And the source of ammonia, see, ammonia is a toxic gas, and it is difficult to store ammonia with the diesel engine units. Okay, and ammonia also has a very pungent smell, and it is toxic, and it is difficult to store ammonia and directly use ammonia. So this is the reason that we are using the AdBlue. We are using AdBlue, and AdBlue will act as a source of ammonia. Okay, सबको समझ में आया? We are using AdBlue because from the AdBlue we will derive ammonia. Ammonia will be sourced from the AdBlue. Disha, titanium oxide provides the substrate. Substrate basically a surface for the reaction to occur. They provide a surface for the reaction to occur, and the catalysts are vanadium oxide and tungsten oxide. They accelerate the rate of the reaction, and titanium, it is providing a place for the reaction to occur. You just have to remember the catalyst. The catalyst is vanadium oxide and tungsten oxide. Nitin, what is the use of catalyst in the AdBlue fluid? We are sourcing ammonia from AdBlue. We are sourcing ammonia from AdBlue. Okay, ultimately we have to achieve this reaction. We need this reaction, NOx plus NH3, and this reaction will produce nitrogen plus H2O. Okay, so the use of AdBlue is just to source ammonia, because we cannot directly store ammonia with the diesel engine units. Is it clear? We are sourcing ammonia from AdBlue. Ultimately, we have to reach this reaction, only this reaction. And the rate of this reaction, it will be increased by the use of vanadium and tungsten oxide. Okay. So AdBlue is, please write, AdBlue is 2 parts of ionized water. 2 parts ionized water plus 1 part urea. So AdBlue is basically aqueous solution of urea. The solution of urea in water. Simple language में यूरिया को पानी में मिला के AdBlue fluid को बना रखा है. Okay. Suppose if this is the diesel engine unit and this is the exhaust of the diesel engine. This is my engine, and exhaust gases, they are coming out from this pipe, and exhaust gases, they include carbon monoxide. It will include obviously the NOx emissions, and we have the particulate matter and the carbon monoxide. Okay, so everything is coming from this outlet. So this exhaust of gases, it will be subjected to a unit, and this unit is known as DPF. Please write what is DPF. DPF is diesel particulate filter. It is diesel particulate filter. So this diesel particulate filter, it will filter out most of the particulate matter, and 85% of the unburned particles, okay, fine particles, 85% of the soot, SOOT, soot is formed by the incomplete combustion. So 85% of the soot, it will be removed by the DPF unit. DPF is diesel particulate filter, and it will filter out the particulate matter. Then the exhaust gases, we will mix with the exhaust gases we have a DEF tank, and in this tank we will have the AdBlue. So AdBlue will be mixed with the exhaust gases. We are extracting AdBlue from the diesel exhaust fluid tank, and from this tank, okay, AdBlue will mix with the exhaust gases. And when the AdBlue mixes with the exhaust gases, A for AdBlue, and AdBlue is mixing with the exhaust, E for exhaust gases, and in this reaction ammonia plus CO2 it will be produced. So this is the first reaction. AdBlue we are mixing AdBlue with the exhaust gas and ammonia will be produced. Yes, Tisha, you have to draw it. Please note everything down in your copies. This is one of the pollution control technology. Okay, draw a very neat schematic diagram in your copy. Okay, मैं गंदा ड्रॉ करूंगा तो चल जाएगा लेकिन तुम्हारा नहीं चलेगा, तो इसलिए अच्छे से ड्रॉ करो एंड नोट डाउन एवरीथिंग. So the AdBlue fluid, it will be mixed with the exhaust, and when the AdBlue will be mixed with the exhaust in this reaction, ammonia plus CO2 will be produced. Okay. Harsh want to ask something. Okay, Harsh. See, this block is the engine. This is the diesel engine, and from the diesel engine, the exhaust gases they are produced in the diesel engine. Okay, so this is the outlet of the exhaust gases, and these gases they contain carbon monoxide, nitrogen oxides, particulate matter. Okay, and hydrocarbons. Okay, the exhaust gases contain the carbon monoxide, nitrogen oxides, particulate matter, and the hydrocarbons. So the exhaust of these gases, it is first passed through the DPF unit, and the DPF unit is the diesel particulate filter. And in the first stage, the particulate matter is filtered out. Okay, DPF will filter out the particulate matter. Exhaust gases सबसे पहले DPF यूनिट में जाएंगी, डीजल पार्टिकुलेट फिल्टर में, एंड यहां से जितना भी पार्टिकुलेट मैटर है वो फिल्टर आउट हो जाएगा. ठीक है. And after the DPF unit, the exhaust gases they will be mixed with the diesel exhaust fluid, and diesel exhaust fluid is AdBlue. Okay, AdBlue को एग्जॉस्ट गैसेस के साथ मिक्स कर दिया जाएगा, और जब हम एग्जॉस्ट गैसेस को AdBlue के साथ मिक्स करेंगे तो इस रिएक्शन में अमोनिया प्रोड्यूस होगी. When we will mix the AdBlue fluid with the exhaust gases, then in that reaction ammonia will be produced and CO2 will be the byproduct. The CO2 will escape from the engine, okay, and the ammonia produced. The ammonia will react with NOx emissions. So here we have the final SCR unit. This is the SCR unit. Okay, and where the reaction will happen over the substrate of titanium in the presence of the catalyst. So in the SCR unit, the ammonia, it will reduce the nitrogen oxides into CO2, into N2 plus water. This is the engine. This is the DPF, diesel particulate filter unit. यहाँ पे सारा जो भी अनबर्न्ड मटेरियल है, सूट है, वो यहाँ से एलिमिनेट हो जाएगा. एंड दिस इज द AdBlue टैंक. AdBlue मिक्स होगा एग्जॉस्ट के साथ, अमोनिया प्रोड्यूस होगी, एंड फाइनली SCR यूनिट के अंदर अमोनिया नॉक्स एमिशन को रिड्यूस कर देगी. सेलेक्टिव कैटालिटिक रिडक्शन. मीनू तुमने लेट ज्वाइन किया क्या क्लास को?
No, sir. Just slip of mind.
Okay, Meenu, fine. हो जाता है, कोई बात नहीं. So the first reaction, Kritika.
So I was asking, ये जो DPF है, diesel particulate filter,
हाँ,
सर इससे particulate matters filter होंगे, तो फिर filter होके कहाँ जाएंगे? एटमॉस्फेयर में जाएंगे?
नहीं, डीपीएफ यूनिट से फिल्टर होंगे तो उस यूनिट के अंदर ही रह जाएंगे ना, बाई सम मैकेनिज्म. या तो वहां पे उसको स्टोर करके रखा जाएगा. सी, वी हैव टू स्पेंड ऑन द रिपेयरिंग फ्रॉम टाइम टू टाइम. ओके.
एग्रीड सर. सर बट अगर हम लोग DPF के बिना ही डायरेक्ट AdBlue को मिक्स कर दें, तो
कोई
क्या
इशू नहीं
होगा?
है.
कोई issue नहीं.
तो आपकी गाड़ी बस थोड़ा सा ज्यादा पार्टिकुलेट मैटर एमिट कर देगी.
ओके सर, ठीक है
ओके.
सर. जी सर.
To achieve almost zero emission of particulate matter, we are using the DPF unit, diesel particulate filter. AdBlue is the diesel exhaust fluid, and DEF is not the tank. In the tank, we are storing the DEF. The diesel exhaust fluid is stored in the tank. Okay. And AdBlue is one such diesel exhaust fluid. So the first reaction is we have the AdBlue. AdBlue will mix with the exhaust. And in this reaction, ammonia will be produced. Then we have the second reaction. In the second reaction, मेनू CO और HC को भी वहां से फिल्टर हो ही जाता है. 50% तक CO एमिशन एंड हाइड्रोकार्बन एमिशंस मैंने बताया था ना, that the hydrocarbons and the carbon monoxide emissions we can reduce them by 50 to 90%. Nikhil, we are extracting ammonia from this fluid. We need ammonia to reduce the NOx emissions. Okay, so AdBlue serves only one purpose. We are extracting ammonia from the AdBlue, and ammonia is the reducing agent which will reduce the harmful nitrogen oxides into the harmless nitrogen gas and water. I hope it is clear now. Kritika, catalyst only enhances the rate of the reaction. And the ammonia is the right word for the ammonia is the reducing agent. Ammonia is the reducing agent in this reaction. Okay, so second reaction is we have ammonia, and ammonia will reduce the NOx emissions into the harmless nitrogen plus water. So SCR technology का use करके we have eliminated the NOx emissions, and SCR में इतना ही याद रखना है. Okay, and you can remember it only by repeated revisions. And please be assured that जो भी हमने क्लास में कराया है that is sufficient. You will realize as your syllabus will accumulate, okay, as your notes they will get bigger and bigger in size, then you will realize that this is so much. Yes, Nikhil, ammonia, it is difficult to store ammonia. There are issues of leakages. Ammonia also has a pungent smell. Nikhil, ammonia is participating in the reaction NH3 plus NOx, giving nitrogen plus H2O. Okay, so in this reaction, ammonia is also getting consumed. No, there is no disadvantage of SCR. There is only one disadvantage, that it is a little expensive technology. It is expensive. And also you cannot use the BS4 diesel with the BS6 diesel engines. BS6 की गाड़ी के अंदर BS4 का डीजल आप नहीं डाल सकते हैं. If you will use the BS4 diesel in the BS6 diesel car, then the SCR unit, okay, and the DPF unit, they will be damaged. See, our major target is to reduce the NOx emissions, and we will achieve 90% reduction, at least 90% reduction in the NOx emissions.
So,
Yes, Kritika.
सर अभी तक मेरे को जैसे समझ आया था उस हिसाब से तो सर BS6 में इंजन का मैकेनिज्म बदला है, राइट?
हाँ,
सर डीजल भी बदल गया है.
इंजन्स को भी अपग्रेड किया है एंड फ्यूल को भी अपग्रेड किया है.
अच्छा, मतलब सेपरेटली डीजल भी है. ओके सर.
हाँ, जैसे कि BS4 कार्स एंड BS6 कार्स के बीच में डिफरेंस है. ओके, देयर इज डिफरेंस इन द टेक्नोलॉजी that both the cars are using, and there is also difference between the BS4 and BS6 cars, BS6 petrol and diesel. Okay, there is a difference between the BS4 and BS6 petrol and diesel. You can use the BS4 petrol with the BS6 petrol cars, but we cannot use BS4 diesel with the BS6 diesel cars. Don't go into that. Okay, I think that is not important for the UPSC, but we cannot use the BS4 diesel in the BS6 diesel cars. And the difference between the BS4 and the BS6 fuel, in case of diesel, the difference is of sulfur content. Okay, the difference is of the sulfur content, and if the sulfur content is high, then the fuel will burn with the less efficiency. If the sulfur content is high, then the fuel will burn with lesser efficiency. Both are harmful, Kritika, both are harmful. Okay, we are not differentiating between the pollutants. Both the sulfur dioxide, the sulfur emissions, they are causing the acid rain. Okay, and they are also the component of the smoke, and they are equally harming our lungs. And NOx emission, they are responsible for the photochemical smoke, for the production of the ozone and the PAN. Okay, and NOx emission, they are also harming our lungs. So such kind of questions can never be framed that which is more harmful, NOx or SOx. But prima facie, it appears that, okay, NOx emissions, they are slightly more harmful. But that is absurd to talk about, to compare between two pollutants. Okay. So the higher sulfur content, it means lesser efficiency. The fuel will burn with lesser efficiency. And if the sulfur content is less, the fuel will burn with higher efficiency. Okay, this is one point. And now if the sulfur content is more, then the lubrication effect will be more. If the sulfur content is more, then there will be lesser efficiency in the burning of the fuel and the lubrication effect is more. But if the sulfur content is too less, the fuel will burn with higher efficiency, but the lubrication effect, it will also reduce. So lesser sulfur content, it can lead to the wear and tear of the machinery. And the higher sulfur content, the lubrication effect will be high, but the fuel will burn with lesser efficiency and more of the particulate matter will produce. So in case of diesel, BS4 and BS6 diesel, there is a major difference in the sulfur content. And if you are using the BS4, in the BS4 diesel, we have the higher sulfur content, and that higher sulfur content can choke the DPF unit, the diesel particulate filter unit, okay, in the BS6 cars. Don't go into that. You were insisting, इसलिए मैंने बता दिया. Nikhil, see the sulfur, there are two effects of sulfur. If the sulfur content is high, then the fuel, it will burn with lesser efficiency. And the second property of sulfur is that the higher sulfur content, okay, there will be lubrication effect inside the engine. The parts of the engine, okay, they will be well lubricated and there will be less wear and tear of the machinery. These are two different things. Don't get confused.
You are now. So I have a question.
Yes, Meenu.
Like in BS6, there is 25% deduction of NOx in petrol engine.
Okay.
Regarding to petrol engine, then is
Yes.
there any other technologies using to reduce this NOx in petrol engine or the same technology?
Yes, petrol engines, they are not using the SCR. And which technology the petrol engines are using, that I don't know.
Okay.
Okay. And that I do not know because that has not come in the newspapers, that what technology the petrol engines they are using. We are studying SCR because it was in news. Okay. And if the technology that is used with the petrol cars, if that was also in news, then we would have discussed it. मेरे ख्याल से अब सबको समझ आ रहा होगा कि हम किस डायरेक्शन में चल रहे हैं और हम किन चीजों को स्टडी कर रहे हैं. Okay, I hope everyone is clear about it. We are studying only those things, only those technologies which are in news. And please remember, keep it in your mind that the UPSC examiner, okay, he will also be reading only those news. So he will frame the paper from the newspaper only. Whatever be in news, okay, he will frame the question paper from that thing only. ये बात सबको समझ में आई कि हम किन चीजों को कैसे पढ़ रहे हैं. So SCR was in news, the BS4, BS6 was in news, and they will not ask anything which is not in the public domain. तो selective catalytic reduction सबको क्लियर है. बस दो रिएक्शन, SCR के अंदर सिर्फ दो रिएक्शन है और दो रिएक्शन भी नहीं, सिर्फ एक ही रिएक्शन है. अगर इतना भी याद रखोगे that from the AdBlue we are sourcing the ammonia. Okay, then there is only one reaction. We have ammonia plus we have the nitrogen oxides and it is producing nitrogen plus H2O. There is only one reaction. And what is this ammonia? Ammonia is the reducing agent. Reducing agent is ammonia. And the catalyst is vanadium oxide or tungsten oxide. I hope this is clear to everyone. And we are achieving the 90% NOx emission reduction by the use of SCR technology, and it is used with the diesel engines. Okay. So we have to start with the gravitational waves. Nikhil wants to ask something. Let's wait for his question. See, the ammonia is participating, Nikhil, ammonia is participating in one chemical reaction, and in that chemical reaction, a harmful pollutant, it gets converted into a harmless component. So ammonia is serving one purpose. Ammonia is participating in a chemical reaction, and in that chemical reaction, okay, one pollutant is getting converted into the harmless component. So the outcome of that reaction is the production of the harmless components, okay, and those harmless components, they are released in the atmosphere. I hope it is clear to you. Ammonia is participating in a chemical reaction, and the product of that chemical reaction, they are the harmless components. They are nitrogen and they are water. Okay. Okay. See, NOx emission, NOx is the enemy, and NOx को eliminate करने के लिए अमोनिया का यूज किया, and NOx and अमोनिया दोनों वहां पे खत्म हो गए, harmless products वहां से produce हो गए. Now, do you have any idea about the gravitational waves? What comes to your mind when you hear about the gravitational waves?
Sir, the pull of the objects from, when we cross the objects, it pulls the objects towards the. Sir.
Okay, Nikhil. Meenu is saying it is related to tides. Kritika is saying it exists between two objects. And Frankie Singh is right that it is the ripple in the space. So Frankie is right. Plug. Yes, plug. Gravitational waves, they are the ripple in the space. Very well. तो द ग्रेविटेशन चैप्टर तो 10th क्लास में आई गेस सबने ही पढ़ा होगा. Yes, Nikhil, both the sun and earth have the gravity. Subhojit is saying waves generated by the accelerated body. Yes, plug. They travel with the speed of light. Aishwarya is saying cosmic ripples. So all of you are right. Okay, but the gravitational waves, they are a complex phenomena, and we will try to understand the gravitational waves in these simple terms. So Newtonian mechanics सबने पढ़ी है, and Newton has given one formula, and what was the gravitational force formula? We have a gravitational constant G and m1 m2 by r square. So this force, the force of gravity in the Newtonian picture, okay, from the perspective of Newton. In the Newtonian picture, the force of gravity, it is related to the mass. Any two object, okay, if they have any mass, any finite mass, then they will attract each other by the force of gravity, and whose magnitude is given by this formula. So this force is inversely proportional to the distance. Okay, it is inversely proportional to the distance squared, and it is directly proportional to the product of masses. So from this equation, we get the information that the source of gravity is mass. if any object has mass, okay, then it will exert the gravitational force. And the gravitational force exerted on one particle, on any body, it also depends on its mass. तो जो फोर्स लगा रहा है उसके मास पे भी डिपेंड कर रहा है, एंड जिस पे फोर्स लग रही है उसके मास पर भी डिपेंड कर रहा है. So in the Newtonian picture, this was the gravity. Okay, and you all have heard that story that Newton was sitting beneath the apple tree and एक सेब आके उनके सर पे गिरा, and he get this idea that Earth is attracting things towards the Earth's surface. So that was the notion of gravity. But the Einstein came with the idea that gravity is not a force. Okay, so with the Newtonian mechanics, we can explain the rotational motion of the moon around the earth, we can explain the tides, we can explain the all the cricketing shots using the gravity, but we cannot explain the larger universe, the cosmos, in the Newtonian picture. We cannot explain the universe in the Newtonian picture. So Einstein witnessed gravity not as some kind of force. Okay, Einstein saw it as the distortion of space. I will come to it. What is distortion of space? Einstein said that gravity is nothing but it is the distortion of the space-time. Okay, we do not have a force due to the mass, but instead the space, it gets distorted because of the mass. अभी तक मैंने जो बोला समझ आया कुछ? कोई बात नहीं. आइंस्टीन अगर इतनी आसानी से समझ में आ जाएगा तो फिर है ना. See, in those times, the Einstein, he came up with his theory of relativity, and his theory of relativity, it was not understood. Okay, it was not very well understood in those times, and it was okay. People considered the special theory of relativity as absurd, and then the same thing is with the general theory of relativity. In the 1915-16, Einstein came up with the general theory of relativity, and the general theory of relativity, okay, it explains the gravity. The general theory of relativity explains the gravity, and the Newton's formula, that is also an attempt to explain the gravity. Okay. And in the special theory of relativity, the Einstein, it has discussed about the structure of space-time. So उन दिनों में भी आइंस्टाइन की थ्योरी इतनी वेल अंडरस्टूड, मतलब लोगों के समझ ही नहीं आई. और आइंस्टाइन को जो 1921 में नोबेल प्राइज मिला, वो अपने इन ब्रेक थ्रू वर्क्स के लिए नहीं मिला. He was not recognized for his works on the special relativity and the general theory of relativity, and he got the Nobel Prize for the photoelectric effect. It was a very simple phenomenon. He got the Nobel Prize for the photoelectric effect, and if you are not getting it in the first time, okay, that is not a big issue. I will try to come up with analogies. See, सभी ने देखा होगा, if you will throw the stones, so then the stones go in a parabolic path. सभी ने पत्थर फेंके होंगे लाइफ में, पत्थर फेंका होगा, कुछ भी फेंका होगा, and everything follows a parabolic path, isn't it? ओके, ये बात सबको समझ में आई। और एक और चीज पे सब एग्री करेंगे, इफ देयर इज एनी आइसोलेटेड बॉडी, अगर किसी बॉडी पे कोई फोर्स नहीं लग रही है, ठीक है, किसी भी तरह की कोई भी फोर्स नहीं है, देन दैट बॉडी विल मूव इन द स्ट्रेट लाइन। वो जिस भी स्टेट में होगी उसी स्टेट में रहेगी। इफ द बॉडी वाज मूविंग इन अ स्ट्रेट लाइन, इट विल कीप ऑन मूविंग इन द स्ट्रेट लाइन। एवरीवन विल आल्सो एग्री ऑन इट। ओके, अगर कोई फोर्स नहीं है, द आइसोलेटेड बॉडी, it will keep moving in this straight line. So Einstein said that because we have the earth and earth has mass, okay, so the mass does not exert any force, but instead the mass has distorted the space around us. The mass has, okay, it has distorted the space. So जब भी आप पत्थर फेंक रहे हो, then the mass is not exerting any force on the stone to come down. Instead, the space is curved. Because space curved है, इसलिए पत्थर एक curved path में गया. Okay, when the space was flat, तो पत्थर straight line में जा रहा था. I think यहाँ से कुछ समझ में आया होगा कि why the space is curved. The space is curved because of the mass. And when a stone is left to itself, you have thrown it, you have discarded it, then it will follow the shortest path. Okay, it will, like anything, will move in a straight line when it is left to itself. Okay, when the body is isolated, in a similar way, any particle, it will follow the trajectory of the space, the curved path. It is related to the geometry of the space. So Einstein discovered that the space also has a structure, a geometry. Okay, the stone is following a curved path because the space is distorted. I think now you are getting some idea what is meant by the distortion of the space. So the mass is creating distortion in the fabric of the space-time. ज्यादा फिजिसिस्ट थोड़े बनना है, बस इतना समझ लो that because of the mass we have the distortion, the geometry of the space time, it will change. The same thing is with the time. Time is not absolute. Okay, time is also relative, and the mass it also creates the distortion in the time. Okay, so these gravitational waves, these are the ripples in the fabric of the space time. These are the ripples in the fabric of space-time. Okay. We will continue from here in the next class on Monday. All of you must have seen this diagram in the newspapers or somewhere else. Okay, have you seen this diagram? See, if two massive objects, they will collide with each other, what will happen? They will create a ripple. Now these two massive objects, they are creating a ripple in the fabric, and this fabric is, it is for this fabric is of the space time. So the massive bodies, they can create ripples in the fabric of the space time. And on the earth, okay, there was an attempt to detect these ripples in the fabric of the space time. So we have discovered precisely these ripples in the fabric of the space. Okay, so the gravitational waves, these are the ripples in the fabric of the space-time, and we will talk more about the structure of the universe on Monday, and we will continue from, okay, and we will start with the Big Bang and some facts about the universe, and then we will proceed Yes, Kritika. Now that we have the technology, every now and then we will receive the gravitational waves, and our understanding of the universe, it will only increase. See, the primary reason that we are studying all these, okay, the world is interested in the gravitational waves because we will get to know more about our universe, the structure of the universe. We are exploring the structure of the universe. So it is not very easy to understand what the Einstein thought about the world. Okay, so this is all from my side, and we will meet on Monday and we'll continue this topic. So thank you from my side. Goodbye. Take care.